now discuss the multiplication of a matrix by a scalar. Scalar is a number, as we told you, and we gave you 4 examples also to illustrate that point. Now we are going to discuss the multiplication of matrices. Multiplication of matrices, first of all, we have to find out that which matrix can be multiplied. All the matrices can't be multiplied with each other. So that is why it is called compatibility for multiplication. When can 2 matrices be multiplied with each other? Number 1, it is very important to understand that all the matrices can't be multiplied to each other, but all the square matrix of the same order can be multiplied. That is also there. All the square matrix of the same order, they have to be of the same order, then they can be multiplied. You remember the order of the matrix was number of rows into number of columns. From here we will start. The order of the matrix was number of rows into number of columns. If there are 2 matrices, suppose I say matrix A and matrix B, they can only be multiplied. These both are matrices. A and B both are matrices. So when can they be multiplied? If number of columns in A, that means number of columns in matrix A, number of columns, remember that, number of rows into number of columns, reverse it for remembering. Number of columns, if number of columns in matrix A is equal to number of rows in B, number of rows in matrix B, if number of columns in matrix A, we can call it first matrix, for convenience, and this can be called second matrix. So if the number of columns in the first matrix is equal to number of rows in second matrix, like here B is the second matrix, number of rows in matrix B are equal. If they are equal, then they are said to be conformable or compatible for multiplication. If number of columns in the matrix A, which I am also saying is first matrix, if the number of columns in first matrix A is equal to number of rows in second matrix B, then A into B is possible, otherwise not. The matrix multiplication of A and B is only possible if the number of columns of matrix A, which is the first matrix, is equal to number of rows of the second matrix. And it is easier to remember, number of rows into number of columns is the order of the matrix. So for remembering, just reverse that and say the number of columns in the first matrix or number of columns in the matrix A is equal to number of rows in matrix B, then the matrix multiplication A into B is possible. For B into A to be possible, again the same thing has to be followed. That means number of columns in B should be equal to number of rows in A, then multiplication B into A is possible. It may be possible that A into B is possible, but may not be B into A is possible. So number of columns in matrix A is equal to number of rows in matrix B, then matrix multiplication is possible. This is the first most important condition of the matrix multiplication. The other thing is that, as I said, that matrices of square matrices of the same order, like I have taken 2 matrices here, A and B, they are of the order 2 into 2. They are always possible. Why it is possible? Because number of columns here is 2 and number of rows are here 2 because they are of the same order. They are a square matrix of the same order. So that is why the matrix multiplication is possible. And the order, the final answer will be of the order 2 into 2 only. So now we are going to discuss that how do we multiply one matrix with the another. First of all, as I said, number of columns in the first matrix should be equal to number of rows in the second matrix. And here the question is that if they are the matrix of the same, two square matrix of the same order, like A is there, which is 3, 4, 0, 5, and then B is there, which is 1, 2, 3, 4. Here the order is 2 into 2. Here the order is 2 into 2. Number of columns are 2, number of rows are 2. So matrix multiplication is possible. As I said, the square matrix of the same order are always conformable for the multiplication. Now, how does the multiplication takes place? It will take 4 steps for me to explain, and I will explain each step separately so that it is very clear to you how do we multiply. Step 1. In the step 1, we take the first row. First row is here. We take the first row and multiply it with the first column of the second matrix. First row of the first matrix is multiplied by the first column of the second matrix, each element to the corresponding element, like 3 into 1 plus 4 into 3. 3 into 1 plus 4 into 3. I am leaving the left blank here. So the first element of this matrix is obtained by multiplying the first row into first column. So what do I get? I get 3 1 3 plus 12. So I get 15 as the first element. 15, and I still have to get those 3 elements. First row into first column. Now let us see this step 2. Now what we will do is, we will multiply the first row into second column. First was first row into first column. Now first row into second column, or let it be, we'll write separately so that it is very clear to you. First row, first column here. Now in the next step I will write again A and B. A is 3, 4, 0, 5, and B is 1, 3, 2, 4. In the second step we are saying first row and second column. Here it was first row, first column. Now first row into second column. Please understand, already we have got the first element as 15. We have got the first element of the matrix as 15. Now let us multiply 3 into 2 plus 4 into 4. So you get the second and third and fourth are left here. What will we get? 15. 3 2s are 6 plus 4 4s are 16. 6 plus 16 is 22, and this is left here. So in the first step I multiplied the first row and the first column. First row and the first column. like 3 into 1 plus 4 into 3. 3 into 1 plus 4 into 3, that is 3 plus 12. I got 15 and I left the rest as the blank. In the next step I am doing is first row into second column. That is 3 into 2 plus 4 into 4. That means 6 plus 16, which is 22. So we have got two elements of this matrix, A into B. Now let us go to the third. Let us go to the third step. Now I am rubbing it off. We are going to the 15 and 22. We have got the elements 15 and 22. Now for the next step, third step, step 3. For the step 3, what we are going to do is, we are going to we have got 15, 22. Now we will, like we had taken the first row of the first matrix, now let us take the second row of the first matrix and the first column. So 0 into 1 plus 5 into 3 and leave it blank. So what will you get? 15, 22, 0 plus 15, it will be 15 and blank. So first row, first column, first row, second column, from that we got 15, 22. Then we are saying second row, first column, and this step 4 will be second row, second column, 15, 22, 15. So 0 into 2 plus 5 into 4, which will be 15, 22, 15 and 20. So we have explained it in 4 steps, step by step, that in first step what we are going to do, in second step what we are going to do, in third step and the fourth step. But when you come across a question, you are going to do all the things together. You're not going to do it separately. It was only done to explain it to you that how we multiply two matrices. And again, I will say that number of columns in first matrix should be equal to number of rows in the second matrix. Then only matrix multiplication is possible. Thank you.